All right, Integrated Math 3. We are moving on with our exponential unit here, and we're going to be talking about a brand new topic today that might seem confusing at first, but hopefully with a couple examples and a little bit of thinking, you'll be like, oh, okay, that's not too bad. It makes a lot of sense. We're talking about what's called a logarithm, which for me, when I first learned about or heard about them, super confusing. Never really fully understood them until I got to college, but I think that's just because it wasn't really broken down for me in the right way. So hopefully we can go ahead and get you guys in full understanding of what they do. Let's go ahead and get started. Okay, so in your notes, you're going to go ahead and you might start a new page or draw a line from what we did. We didn't really write many notes for the last lesson. We just had examples. And really, you just need to practice the delta math to make sure you understand all those exponent rules. But this is going to be more based on what we did last semester at the very end. We have these three exponential equations that you guys are going to solve. Okay, so let's go ahead and I'm gonna pause this. I need you to write down numbers 1, 2, and 3 in your notes. And I want you to, based on what you know, I want you to try and solve each one of these equations, 1, 2, and 3, okay, without my help. All right. I feel very confident everybody can do number 1. Shouldn't be too hard. But we want to know, for each one of these, we want to know what is x equal to for each and every single one. Okay. So I'm going to pause it, give you a few moments to look at these and solve them. And you're going to actually reply in play pause it here. You're going to put your answers. And if you don't know how to do them, just write I don't know. Okay, that's fine with me. But I just want you guys to think about what would x be for each one of these situations. So let's go ahead and do that. Okay, so you had time to work on these, and we are going to. I'm going to go through these and talk about how you should have thought through them, and we'll see if you got it correct. So let's talk about number 1. Well, what x value? Because what you have to do here is think, okay, well, what x value is going to go in here, which means I'm raising this 2 to some power that gets me 4. Well, 2 to what power is 4? Well, I think most everyone knows that 2 squared is 4. Okay? If you had a calculator handy to do that, you could, I mean, it's not that complicated, but you could raise 2 to the second power. You know that it's 4. You can sort of check this if you want. But I think most people have that common knowledge that it's 2. Now, we step it up just a little bit, right? We have 3 to the x minus 1 equals 27. Well, right off the bat, if we don't think about what's up here, and we just said 3 to some power equals 27, hopefully most people would arrive that it should be 3 up here, right? 3 would be x, but we have x minus 1, okay? So what does that mean x needs to be? If I need that final exponent to be 3, well, it should be a 4, right? Because 4 take away 1 is 3. 3 to the third power is 27. So hopefully everybody got 4. And hopefully that wasn't too confusing to answer that. Okay? So far so good. And number 3 is really where we run into an issue. Because I think a lot of people would say, okay, well, there is no answer to this, right? This doesn't work. 2 to what power equals 9? Well, that never happens. 2 to the second is... Oops, hold on. 2 to the second is 4. Go up, copy it. 2 to the third is 8. 2 to the fourth is 16. Is it ever 9? It's not. So, but some of you, if you're clever and you didn't say, oh, I give up, you'd say x is, we would say greater than 3, but less than 4, right? So there's we know it's somewhere in between there, but that's not going to be good enough, okay? For this chapter, we are looking for the power that works. And what that means is it's going to be a decimal, all right? It's going to be a decimal. So what we're going to be learning today is our tool for figuring out what that decimal is. When mathematicians were introduced to this, how did they come up with a method for finding this? So what we really need is an inverse operation. Well, just like if we had, so my example here, if we had a problem, 2x equals 4. Now we know what that is, but what if it was 2x equals 5, right? Well, there's no number that we multiply by 5, but we know that if we divide both sides by 2, we get x alone, and that is 5 halves, right? And we know how to do that because it's an inverse operation. That we have to find out what is our new inverse operation. And by the way, you didn't have to write that. What is this inverse operation we need to get this x by itself? How do I get x on one side of the equation with none of these numbers? That's the real thing that you should be thinking right now is, how do we get that x out of the exponent? Okay, well, we have a way, all right? It's called a logarithm, okay? So I need you to write the word, here it is up here. We're gonna copy it down here. Let me put this. So put the word logarithm, and we have our definition. You can either just put colon by the logarithm, or you can say logarithm definition. And what I have highlighted in yellow is what I really want you to write. Okay, so I'm going to put quotations around these right here, because these are sort of statements. What is a logarithm? What does it do? And then we're going to set one up. We're going to set up a couple of them. Okay, so a logarithm, in its simplest form, a logarithm answers the question, and you're going to write, how many of one number do we multiply to get another number? That's what a logarithm is doing. Next, the logarithm answers the question, what exponent do we need for one number to become another number? All that should make sense. What x value, and I'll go back to that slide, what number do I need to raise this to get 9? That's what a logarithm is doing. And this final bullet point, which is, I have it underlined, I want you to underline it in your notes. A logarithm is the inverse of an exponential. And this word inverse is going to be very important as we continue through this unit. We're going to be talking a lot more about this idea of inverses, which we already know inverse operations, add and subtract are inverses, multiply, divide are inverses, squaring and square rooting are inverses. We have now introduced this idea, we've introduced this idea of an exponential, or finding that exponent. The inverse of that is this logarithm that we're now introducing, okay? So I'll pause, make sure you have time to write this. All right, so here is our general rule. So I need you to write this right here. I'll even highlight it just so that you guys know exactly what I want you to do. Where's my, hold on. So right up here, write that general rule to create a logarithm from an exponential equation. So you're going to write this, you're going to draw this diagram. I'll pause and give you a second to do that. We're going to use this to help us answer a couple of our questions. We're going to go back to that first slide and use this for every single one of the questions. All right, so I'm going to actually copy this so we have it for reference. Go back up here, and we are going to, I don't want to draw. PowerPoint is being weird right now. I want to be able to, I don't want to draw. Okay, so we're going to paste that. We have that handy. Let's use this to help us solve each one of these. So now I do want my draw tool. So we're going to change this equation. I want to delete all of these. And we're going to rewrite these into their logarithmic form. So we see we have this. A is the base. So we're going to start. I want you in your notes to go back up to these problems that you worked, and let's rewrite them. So it's log, always log, And then we have this subscript, this little a right here. That is our subscript that we're going to be using. It's always going to be this base. So what is our base in this one? Well, it's 2. Log base 2. Then we put in parentheses the value that we want to find. This is the number we're trying to get. So 2 to what power equals what's in here? And actually, it's not 9 yet. It's 4. So 4. And that's always equal to, so this power is going to go on the right side here. Part of the next test is going to be you have to be able to go from exponential to logarithmic form and vice versa. Okay? You have to be able to exchange between these forms. You will get practice with that on Delta Math for sure. Okay? Now we have this set up. Now, let's go ahead and do the rest of these as well. So let's go to number 2. Log. What's the base? Well, the base is always the number that's being raised to the exponent. So the first one, it was 2 that was being raised to the exponent. Here it's 3. Inside the parentheses, what's going to go in there? Well, it's always the number that you're trying to set it equal to. Again, we can refer to this chart to help us out. The x is going to go right here. So this x goes here. That's what that arrow is showing. This is going to be equal to the exponent. Well, what is our exponent? Well, it's all of this. All of this is going to go here, x minus 1. Okay, we're going to leave that there for a second. We'll come back and we'll finish that one up. Let's do this last one here, the one that we didn't know the answer to, but with the logarithm, we're going to be able to figure it out. So let's go ahead and convert it. The base is 2. So I say log base 2. That's how you'll say that out loud. Of, so it's log base 2, the number that goes in here, you say of 9 equals x. All right, now it's time to actually figure out how to do this. So let me go ahead and pull up some calculators here. Okay, so we're going to start with old reliable here, the TI-80, because I know I have a lot of people that are TI-80 users. So let's talk about how you would go about doing this. Okay, so you have these buttons down here. We need to talk about these. You have log and ln. Okay, ln is important. We'll get to that, but let's go ahead and press the log button. Okay, so what we have here, whenever you see log by itself, and I'm going to make a new slide here. Let me, I'll stop drawing. We'll call these logarithm FYIs, okay? These are going to be important. So we're going to say log x here is the same as saying log base 10 of x. So really what I'm getting at here, let me maximize this. I want you to write this logarithm FYIs just down below. If you see a logarithm with no base, it's automatically assumed to be 10. That's very important because you're going to see a lot of those, but it's automatically assumed it's 10. So what we have here in this TI-80 is it's automatically putting 10. Okay, so what do we need to do to get where we can put in a base? So if we clear that, we want to be able to put in a base to answer this question here. We need to do this. You're going to press math, and you're going to go down all the way. You have to go pretty far down here. You're going to go down to, all right, right here. See, it says log base. It's A. Once you hit math, you go all the way down to that, hit enter. Now we can type that in, 2. And inside of here, we put 4. We hit enter. Look what we get. We get 2. So we say x equals 2. That's how we're finding these. So we are going to need a calculator to find these logarithms. Next, Inspire. How do we do it on there? My Inspire users, you're going to hit Control 10 to the x here. And it automatically puts it into that form. We put 2, 4, hit enter, gives us 2. Okay. For those that do not have either of these calculators and you're trying to do these at home, I looked at some websites to use for this. This is the one that I landed on that I like the best. It's called Symbolab. I'm going to pause the video and link it so that those that don't have the calculator, you can use this. You're just going to hit this log button, 2 to the 4, go. And really all you need is this last one here. Okay, it's equal to 2. All right, it's equal to 2. So those are the different ways that we can find these logarithms. So let's continue. I'm going to stick with the 80 series for the rest of these. Go to this next one here. So on number 2, erase that, we need to find, because we're not going to get an answer right away, but we need to find log base 3 of 27. So in your calculator, we'll press math, go up to log base. We're going to do 327. What this gets us is the left side of this equation, and it's 3. We already talked about that. So we'd say this is 3 on the left side, and then that's equal to x minus 1. So what we found in our calculator was this. Now we actually have to finish this, but it's pretty easy. We're just going to add 1. So plus 1 goes away. We get 4 equals x. There's our answer. We actually came up with that. It might have been a little bit difficult when we were doing it in our heads, but I think we talked through it. It should have made sense that it was 4, because 4 minus 1 is 3. 3 to the third power is 27. Okay, but we're using our calculator to help us out. Next, let's look at number 3. This is the one where I said, okay, we know it should be a decimal. We also know that it should be between 3 and 4, because 2 to the third is 8, 2 to the fourth is 16. So let's go ahead and try that. Hit math, our log. We want 2 to the 9. And what we expect when we hit enter is to see a decimal. So I'm going to hit enter. There it is. And we'll go to 4 places on this. No, let's go to 2. Let's go to 2. So this is 3.17. Okay, so 3.17 equals x. We knew it was closer to 3 than 4, just because it was 2 to the third is 8. So we knew it couldn't be too much further than that as far as the numbers go. But here's our answer. And that's what we're going to be doing starting off on Delta Math, is you're going to be solving these exponential equations using these logarithms. So let's go ahead and look at Delta Math. Okay, so here is the problem type. Let me go back here. So this is what I gave you a lot of work for the exponent rules, but here are the equations that we're going to be solving, okay, using these logarithms. So this is the first one, the level 1. We'll do both levels and talk through those examples. So it says solve for x rounding to the nearest hundredth. You obviously have a video that you can watch on here, but we need this rule here to help us. So we're going to screenshot this and we're going to work it. Let me go ahead and paste in this. So we have this. We're going to need that. Now there's an issue because we can't go use this. This is not in this format. We need it to be just the base raised to the power equal to a number. So when we were working these questions, we have an issue because this 180 can't be over here. This 180 needs to go away before we're able to solve it. So that's something that when you're working these, you have to realize. So we need to get rid of the 180. We can do that by division. It's an inverse operation. This is multiplying. We divide the 180. It's going to get us 10 to the x equals 60 over 180. So you can simplify that. There's a GCF of 60, so it's 1/3. And now we are in this format, right? Like this, and so the reason we had to get rid of that 180 is because we needed to get in that base power equal to a number. That's what we want every single time we work these. So let's go ahead and convert it into a logarithm. Let's change it from this exponential form to this logarithmic form. change color. So let's change it. We want log. And you have to think, okay, what's the base? Well, the base is the number that's being raised to the power 10. So log base 10. The x equals 1/3. So the number in here is 1/3. So think about this. What is going to cause 10 to become a smaller number? Well, that means we're going to have a negative exponent. It's not going to, we can't raise it to a positive number. We need repeated division. So what is that x value? Well, if we pull up the calculator here, we could actually use, just by clicking this log button, we could do this problem, because this implies, or this right here is showing log base 10. So if I hit enter, we get our answer. Let me just do that with base anyway. You can, if you're just always comfortable putting in the base 10, you can. And let's put 1 divided by 3, hit enter. You're getting the same thing. So what does Delta Math want? They want to the nearest hundredth. So this would be negative 0.48. Negative 0.48. That's what we want to type in. So let's go to Delta Math and check that out. Negative 0.48. Submit answer. We got it right. So what they have here is they do things a little bit differently than what I'm showing. So I'm not really sure that you're going to find their explanation as useful as what I'm doing. You can fully expect to have a calculator. Say this is EOC. This will be on the calculator portion. So I do not like what they have on here for video for explanation, and I'm pretty sure that the video is probably going to explain it similarly. It's a 10-minute video.
Common law.
So yeah, he's doing change. You can watch that if you're interested in it. But he's doing what's called change of base, to where you'll always be able to get it to log base 10. But I would say it's going to be more efficient for you to use my method. Okay, if you need more help with this, send me a message and I'll do that. Let's work one more problem here. Let me find one. Let's see if they have anything different. Okay, yeah. Let's talk about this, because this is another FYI here. So let's work this problem. And again, I want to paste in my rule. So the first thing we want to do is we need to get rid of this 8. We need just the base to a power equals the number. So we're going to divide 8 from both sides. 8 goes away. We end up with E, which we already know what E is. We introduced that. That's Euler's constant. Learned about that. Over 4. Remember, E represents that continuous compound interest, so that's the exponent. This is equal to 1/8. Okay. Now, when we change this to a logarithm, we have log base E of 1/8 equals x over 4. Let's write in our notes another FYI here. If I can get it to drop to right for me. So the next one, and I need to insert an equation here. Let me pause that. Okay, so log base E, whenever you see that, it has a special notation, which is ln. Okay, this is known as, and you're going to write this, natural log is what it's called. So normally you'd think it would be NL for natural log, but it's always ln. So you'll notice that on the calculator for those using the 80 series, you'll have ln. Let's see, on the Inspire, you have control, and it should make sense, e to the x right here. Control e to the x, you get ln, right? Let's see if they have that on that one calculator site. ln, where's that at? They do not have it. So you got to make sure, yeah, that they don't have it on there. But most scientific calculators actually have that. I think that Delta Math actually has a calculator that you can use. Yeah, here's a calculator. So function, you could put L in here. So that would work as well. Yep. And I'm actually going to see what that looks like. We're going to practice with that. But for this, let's go back to our work. We can actually change this to natural log of 1/8 equals x to the 4th. Let's keep working that. So actually we want to put in natural log of 1/8 equals, we get -2.0. We want to round to the nearest hundredth. That's, yeah, we're sort of waiting for the end on that. I'm going to round to 4 places. -2.0794. That's the left side here. Now, how do we get x by itself? Inverse operation is multiply by 4. So times 4 on both sides. This goes away. We get x is equal to this number times 4. Now we want to round to the nearest hundredth, so I'm going to put -8.32. And that's the answer that's going to go here. Let's look at what that, I want to see what that does in Delta Math. We know the answer. If I do natural log, but we got to do 4. Go back to, no. 4 times, let's go to our functions, natural log of 1 divided by 8. Let's see if this works. It should. They didn't like that. Okay, so they I don't know how you're supposed to use that calculator to do this stuff, because I'm pretty sure he uses it in his example. Oh, hold on. You can use this calculator up here. It has it built in. Yeah. Look at the top right. Click this calculator. You should be able to just do, let's do that again. 4 times natural log 1 divided by 8. Messing that up. Hit enter. Shows it over here to the side. See that? -8. So that's how you want to do it. You don't want to actually type that into the space. You would type it in using this calculator up here. Graphing. Oh, you have a graphing calculator too? Oh my goodness. That's a mess, awesome. But you really just want to click the button, get this calculator, scientific. There we go. You may even want that. Let's see actually if it has the logs. It just has log there. It doesn't, you can't pick your base like the other calculator. So basically if you have an Inspire or a 80 series, you're in good shape here, okay? Otherwise you're gonna struggle a little bit here. Okay, so there's that. Let's look at one more question type and then we're gonna be done. This is the level 2. So here we have the examples. We finished up last semester talking about this idea of interest, compound interest, right? So we have our compound interest formula, which you'll get on the next test as well, where it says a person invests $2,000 in a bank. The bank pays 4.75% interest on compounded quarterly to the nearest 10th of a year. How long must the person leave the money in the bank till it reaches $3,500? So let's go ahead and set this up. So we're going to put our equation over here. And what we have here, we have 4.75%, that's R. It says compounded quarterly, that's N. N is equal to what? Well, quarterly means 4 times a year. The N is 4. You start with $2,000, that's P, and you want to know when will it reach 3,500. So we have A. The only thing we don't have is T. We don't know what it is. We don't know what T is. So it says how long must the person leave the money? That's what we know. How much time is going to pass? And I think last chapter or last unit with these exponentials, I had somebody ask, well, how do we solve for that exponent? But now we have the tool to do it. So let's go ahead and set it up. You start with, or you want there to be 3,500. This is A, the amount after a certain amount of time, 3,500. You start with the principal P, $2,000. You're going to multiply that by you have your interest rate over the compoundings. So that's 1 plus R over N. R is, you got to change that to a decimal, 0.0475. Over N is 4, raised to the 4t. There's our equation. Now I want to simplify that a little bit. I want to simplify what's inside of this fraction. So let's go ahead and do that. I'll use this to do that. So we want 0.0475 divided by 4. That's this value. I want to add that to 1. So we know that this is going to be, I'm going to rewrite this down here. 3,500 equals 2,000. Whatever. Times, and we want, it's right here, 1, I'll go to 4 places, 1.0118 or 119. 4t. Okay, and also I want to make sure I have this here so that we can look at it. Let's move that down. That there so we can convert this. So we're not in this form. What do we need to do? Well, we need to get rid of this 2,000 for both sides. Really hard to see. Let me change that to let's change it to red. So divide the 2,000 away from both sides. And that's going to get us 1.0119, the 4t. And then we're going to divide the 3,500 over 2,000. We get 1.75. Okay, so 1.75. Now we want to use this formula, this general form here, to convert it into the logarithm. That's how we're going to answer this. That's how we solve for this variable. Now that we have it just the base and the power and a number, we can convert it to a logarithm. So we'll make that green. Okay, so it's going to be log. What's the base? Well, it's 1.0119 of, what's the number that's going in here? It's going to be 1.75 equals, we want it to be equal to the exponent. The exponent goes over to the other side, so it's 4t. Not 40, 4t. So let's go ahead and use the 80 series. You're going to press math, log base. You put in that whole base. This is a weird base that we've seen here. This is not something that you could do in your head ever. It's not, you're not looking at the number 2 and saying, okay, what power do I raise 2 to get 4? And we knew that that was 2. Here, there's no real reason that you should ever know the powers of 1.0119. I don't know them. No person would really ever know that. So that's why we're using the calculator to help us out. We want it to be 1.75 in there. Hit enter. And we get 47 I'm going to round that again to 4 places. So 3058. So 47.3058 equals 4t. Now we just need to solve this. We need to solve this for t. So what do? We divide by 4 from both sides to get t by itself. So that gets us t on the right. Divide this. Let's go back to the calculator. Divide by 4. And we get 11. And what does it want us to round this to? Let's see. Nearest 10th of a year. So to 1 decimal place. So we always got to be cautious of our rounding. So we get rounded to 1 decimal place, 11.8. Okay, 11.8. Whatever the units of measure are, I think it's years. It's always going to be, it's going to be years, yeah. 11.8 when we're talking about compound interest. Submit. I got it wrong. I rounded too much. So rounding, it looks like rounding is going to be an issue. Let's go back and talk about how I should have done that then and what you guys can do to avoid the rounding errors. So if I go, let's try this. Actually, let me test something real quick. Okay, so rounding is causing a huge issue here. Let's talk about right here what happened. So I really need to make sure that this number is precise. So I did that. Let me clear all this. If I do 0.0475 divided by 4, there's that decimal. If I add that to the 1, I get this number, which I rounded to this 1.0119. That rounding caused a problem. So when I moved it into the logarithm here, that's what caused the issue. So that's pretty frustrating. But let's talk about how you can make this easier for yourself to type. If you press math, go to the log base. The same thing for Inspires, by the way. Right here, we can go back up and copy that value in like that. That's pretty handy that it's able to do that. And then we're going to type in the 1.75 here, and we get 47.404, which is a little bit different than what we'd originally gotten. Yeah, quite a bit different. Look at the difference between these decimals and the ones that we got on the calculator. That's what's causing the error. Now we divide by 4, get 11.85, which is rounded up, so it's 11.9 on here. And if you look at the delta math here, you can see that that's what they got here. Yeah, that's what they got here. So rounding is an issue. Make sure that you're trying to use as many decimals as you possibly can. Because I don't know if this will always happen where it'll cause issues, but we're trying to try not to round until the very end if you can help it. Okay, because that might cause problems. All right, this has been a pretty long lesson. I'm going to go ahead and stop here, and you can go ahead and get to work on these new sections.